Hi folks, Mr. Long here. We're going to do a screencast on graph sketching of square root functions, and we're going to go through the BEDMAS approach. So just over here, folks, on this side, I'm showing step by step what we're doing. So initially, and what I'll do, you can just see the mouse moving. So the original graph we're going to look at here is oh, there's emails going up. Over here, we have an original graph of y equals root x, and we can see here, where on the left side of shown here, it says the original function, note the key points. So here's our cusp for the square root of x. Square root of 0 is 0. There's the cusp. And if I go over 1, 2, 3, and 4, I would go up 2. So that x is the distance from the x-axis, y is the distance from the y-axis, 4, 2. And we know it has that nice smooth curved response. It gets less and less steep as it goes further to the right. That's the square root of x with the key points. Okay, so and what we do is we compare all our transformations to that as we go through here. So let's now start with our original graph. So I just have to turn things on and off. Okay, so what we're going to start with is the actual function that we're going to sketch is, if you look to the right of the screen now, we're going to sketch this one right here, y equals 2 root negative x minus 3 plus 1. And that's what we're going to sketch step by step. So the first thing obviously is brackets in BEDMAS, and you can see here I wrote down brackets. So what's nice about this, folks, is you can see, I'll turn it on now. So we're going to draw a straight line, and that straight line is in red, and it's, if you look on the left, it's y1 equals k x minus p. Well, k is just plus or minus 1, right? So notice how the graph changes when I change it. So there's plus 1, there's minus 1. Plus 1, minus 1. So minus 1, the graph slopes down. And we need to set our p-value to 3. So there's a p-value of 0. As I move, p becomes 1, the x-intercept is 1. P becomes 2, x-intercept is 2. If I go to 3, and so on. Okay, so that graph right now is, if you look again, I'm doing this, moving the x-intercept. So if we look over here, folks, you can see that the first piece is right here, negative bracket x minus 3. Okay, so negative bracket x minus 3. And we're graphing that straight line. And there's the x-intercept there. And then what we want to do is, so that's the straight line. Now what we have to do is get the square root of all those y values. And I've got one other point that I'm going to put on it, and that's this key point here. And I want you to think about maybe why I've done that. If you look at negative 1, 4, that means I've gone 1 unit, 2 units, 3 units, 4 units to the left. Okay, and I just want to review with you that all of these values here above the x-axis are positive y values. All the values below are negative. And notice that the line slopes down to the right, which means it slopes up to the left. So I guess my question is, where will I be able to draw the square root of that? Okay, and that is our next step. So our next step, number 2, I'm off at the right again, is to graph the exponents, to apply the exponential relationship to that straight line, okay, to the y values of that straight line. So what I'm going to do now is get the square root of the line negative bracket x minus 3, the square root, because square rooting is actually an exponent. So what I'm going to do now is just slide down here, and you can see that it says exponents. So the square root symbol. What happens to the negative y values? So what's going to happen to all these negative y values? Will I be able to take the square root of those? So what we're going to do is we're just going to graph that. And notice it says, oh, there we go. There's our characteristic square root shape. And it does look different from our original one because this one is opening to the left as compared to our original, which opened to the right. And then I'm going to put some key points on there and there. Now we have our key points. So we notice that this one opens to the left, and that makes sense because I can't take the square root of any of these negatives. As I look at the line here, as I look at this line, notice, so right here, what's the square root of 0? 0. Then I go to here, and notice I get the square root of I've gone 1 over from 3 to 2, and the square root of 1 is 1. That makes sense. Then I go over by from 3 to 2 to 1 to 0 to -1. That's 4. And the square root of 4 is 2. Okay, so if the y value here is 4, the square root of 4 is 2. The square root of 1 is 1. Now there's the straight line, and it has a y-intercept of 0 and 3. So to get the y value on the square root graph of the line, it should be the square root of 3. The square root of 3 is 1.73. If I click that, it is in fact 1.73. So it looks like this graph, this black square root curve, the y value on the square root graph is the square root of this red line. The y value is on the red line. Okay, the cusp is there at 3, 0, and our key point is at -1 and 2. I would encourage you to pause it at any time to make sense of this stuff so that you know what's going on. Okay, so what I'm going to do now is just turn off that line, and I'll do that by turning that off right there. Oh no, sorry, I want to keep that on, but I do want to turn off the line. So I just have to go back up and turn the line off. So now what I'm looking at is, after exponents, we have multiplication. Okay, we have multiplication. Oh, and I seem to have gotten rid of my explanation for that. That's okay. So for my explanation, it's this one right here. y3 is equal to a. A is what I multiply by, and then the square root of y1, so the square root of that straight line. Over here, folks, on the right-hand side, you can see that it's y equals 2 and then the root of everything. Okay, so this means the same thing. A multiplied by the square root of the original line. So I'm going to turn that on. And first I'll put a to 1. There's that. So if you look, right now it shows the purple line overlapping. And that's because the a value is 1. If I multiply anything by 1, I get the same result. But watch what happens as I change a. What is a doing? A is becoming more and more positive, so I'm multiplying the y values by more and more. So 1.5, 2.5, 3, and so on. But what if I multiply by 0.5? Well, the y values get smaller because I'm multiplying by a number between 0 and 1. If I multiply by 0, the graph should disappear, and it does because everything is 0. As I move down then, that becomes a vertical reflection because I'm multiplying the y values by negative. Okay, so we'll go back to there, and then we're supposed to have a y value of, or an a value of 2. So that means that the a value is 2. That means I'm multiplying all of the y values in the original square root graph, or in the square root graph, by 2. Okay, it's multiplication and division. So if you notice, go to the cusp. What's the y value at the cusp? Well, it's 0. 2 times 0 is 0, so the cusp does not change. It's invariant. What about at the square root, or at the y-intercept rather? So the y value on the square root graph, the original square root graph, the square root of the line is 1.732. Double of 1.732 is 3.4. Oh, 17 times 2 is 34, so 1.7 times 2 is about 3.4. Okay, and then check this. It's showing a y value of 2, and then I have a y value up here of 4. That's double. Okay, so if you double 2, you get 4. So it looks as though the purple line, the y values on the purple line, are exactly double of the y values on the black line. So on the black curve. So that is an a value of 2 right here. Okay, so I'm multiplying all the y values by 2. Remember that each successive graph, I'm doing the operations on the y values of the previous graph. So in this case, what I did is I doubled the y values from the y values in step 3 are the same as the y values in step 2 multiplied by 2. I'll actually reinforce that. Okay. Last thing after this is, and I'm just going to show this because I'm going to run out of time in about 20 seconds. I'm just going to show the last step here. It's very clear. I'm going to move the a value up 1, or the q value up to 1. So if you notice, folks, what happened here is, if you notice, my q value is up 1. So the cusp moved up 1.